and today we're going to talk about simplifying radicals. So we've dealt with radicals so far in that we've had to simplify perfect squares under the radicals, and we've dealt with estimating, but today we're going to be focusing on non-perfect squares and non-perfect cubes, where we simplify it in that we make the number under the radical as small as possible. So we're going to take some of the parts out because they actually create perfect squares or perfect cubes, and we just try to leave the smallest number under the radical as possible without making it a decimal. Okay, so we're not going to use our calculator so much for this, but instead we're going to use something called prime factorization. You probably have done it before in elementary school. We're just going to do a quick review. Okay, so how do we simplify a non-perfect square or non-perfect cube? We use the birthday cake method. Okay, and again, the birthday cake method is all about prime factorization. Okay, so this tells us prime factorization. Okay, remember prime numbers, very important, are like 2, 3, 5, 7, 11, and so on. They're numbers that can only be divided by 1, okay, and nothing else. So we're going to focus more on these easy prime factors because a lot of numbers that we deal with are divisible by 2, 3, and 5, okay? So here's an example. We need to find the prime factors. Find the prime factors of 36, okay? That's what we're going to do. We're going to use the birthday cake method. So with the birthday cake method, we basically are making a birthday cake when we find the factors. So we start with the bottom tier. Bottom tier of my birthday cake is 36, the number I start with. Well, I got to think, well, what can go into 36? 2 can go into 36, 3 can go into 36, 9 can go into 36, but it's not a prime factor. So on 4 is not a prime factor, so I'm just going to go ahead and do 2. You can do 3 if you want, but it doesn't make a difference. So now I need to come up with my second tier. So 36 divided by 2 gives me 18. Okay, so 18 goes to my second tier. What can 18 be divided by? That's a prime factor. It can be divided by 2, it can be divided by 3, not 5. So I'm going to go ahead and do 2 again. Okay, 18 divided by 2 leaves me with 9. Okay, what can 9 be divided by? 3. Okay, so now I'm left with 3, right? And now I gotta ask myself, well, what can 3 be divided by? Well, remember, I'm making a birthday cake, so what goes on top of birthday cakes? A candle, right? So I need a 1 right here. What can I divide 3 by that would give me 1? Hopefully you guys are thinking about it, but 3 can go into 3 and still give me a 1. So that gives me my little birthday cake with a wonky candle. Alright? Which means my prime factors of 36 are all these numbers on the side here. These are my prime factors. 2 times 2 times 3 times 3. Okay? Finding the prime factors is really going to help us simplify the number under the radical. Okay? So that's what we're going to do right now. Alright, so we have the square root of 42. We're going to go ahead and make our birthday cake. We start with the number under the radical. We need to find the prime factors for this number. Okay? 42 is our bottom tier. What can go into 42? 2 can go into 42. So we do that. We're left with 21. Okay? And what can go into 21? 3. What's left with 3? 7. What can go in 7? 7, because 7 is our prime number. Okay? Meaning we're left with the birthday cake, the candle on top. Okay? So here are our prime numbers. So I'm going to rewrite this to be the square root of 2 times 3 times 7. Okay? To simplify a radical, like a square root with a non-perfect number, when we find our prime factors, if we have doubles of prime factors, that creates a perfect square. Like 2 times 2 would be a perfect square. okay? Which means we can take it out and just put it on the outside. Okay, here we don't. We have 2, 3, and 7. So actually, the simplest form of the square root of 42 is this. Okay? So that would be the simplest because I don't have any doubles here. This is what I'm talking about with doubles. We're going to do another one. Okay? Here I have the cube root of 36. Okay? So here, I'm not talking about doubles anymore because I'm talking about cube root. I need 3s. Okay? So I go ahead and do my cube root. I'm still going to do it the same way and get my prime factors. So I got to get 36 at the bottom. What goes in the 36? 2 goes in there. 36 divided by 2 is 18. What goes into 18? 2. What goes into 2 goes into 18 9 times. So now I have 3. And I have 3 again. And I got my candle on top. Okay? So my prime factors are 3 times 3 times 2 times 2. Okay? Because I'm dealing with a cube here, I need 3s and them to be on the outside. Okay? I don't have any I don't have any triples. Okay? So this one, the cube root of 36, is actually 36. Let me show you a contrary thing. If I was doing the square root of 36, okay? If I have the square root of 36, okay? I know I have 3 times 3 times 2 times 2. Okay? Well, these 3s will give me 9, which is the square root, right? So that means the pairs, just like the pairs, means this could be moved to the outside. Okay? This can be moved to the outside. So I can write it to be 3 times 2. Okay? 3 times 2 equals 6. That's my final answer. Okay? Let's try another one. Okay, here I have to simplify 2 times the square root of 68h to the 7th. I'm going to do it the same way. This, I don't need to do prime factorization for, because I can just write it out h times h times h 7 times. This, I do need prime factorization for. So I got to do my birthday cake. So 68, starting over here, what goes into 68? 2 can go in there. So that leaves me with 34. What can go into 34? 2. Okay? That leaves me with 17. Okay? What can go into 17? 17 can go in there, leaving me with my candle. Okay? Bad, very, very bad candle. Okay, so the prime factors, and now I still have a 2 on the outside of this radical. I got 2 times 2 times 17 times h times h times h times h. That's 4, 5, 6, 7. Okay? Now, since I'm dealing with the square root, I want pairs. Here's a pair of 2's. Here's a pair of h's, and a pair of h's. That means any pair can be moved to the outside of the radical. Once it's paired off, it can get out of the radical. Okay? So here, this 2 is already on the outside. This 2 right here is already on the outside. So I have the 2 still on the outside times this pair, 2, times this pair, h times h times h. These are these pairs. Anything that doesn't have a pair gets left inside. So the 17 and this final h gets left inside because it doesn't have any pairs. It's not allowed to leave. Okay? Last thing I need to do is simplify all of this. So 2 times 2 gives me 4. H times h times h gives me h to the third. Leaves me with square root of 17. This is in simplest form. Okay? That's my final answer. Okay? So I'm just looking for pairs and triples. Last example. I have the cube root of 81, a to the 4th B to the 9th, C, okay? So again, I need to do the birthday cake for the 81, and the A, B, and C, I can expand myself, okay? So 81, okay, what goes into 81? 3 does. I'm left with 27. Okay, what goes into 27? 3. So I'm left with 9. What goes into 9? 3. So I'm left with 3. What goes into 3? 3 with my birthday candle on top. Better candle. Okay? So I expanded out, so I have the cube root of 3 times 3 times 3 times 3 times A times A times A times A, times B times B times B times B times B times B. Alright, I gotta extend it down to the next line. Times B times B times B times C. Alright, so now I have, since I'm working with a cube root now, I need triples. Okay, here are triple 3s, here are triple A's, here are triple B's, another set of triple B's, another set of triple B's right here. Okay, so anything that's circled in red can be moved to the outside. Okay, so this 3 gets moved to the outside. A set of A's gets moved to the outside. A set of B's gets moved to the outside. And there's 3 sets too. Okay? Alright, all this stuff got moved over here. And what's left on the inside is those 3, an A, and a C. Because they are not in a triple. 3A and a C. Okay? Just simplify all of this now. So I have 3AB cubed times the square root of 3AC. And that's how to simplify radicals. We will be doing more practice with this, especially the birthday cake stuff, okay, in class. So if you have any questions, write them down on the side. I'll be happy to answer them next class, okay? All right, I will see you next time. Like the video, subscribe to it, all the stuff you guys asked me to say in the video, and I'll see you next class. Bye.